Good morning, everyone, and thank you for attending. Let's give it 1 to 2 more minutes before we start. Hello, my name is Yang, and for today's webinar, we have how to protect ISTIO and other service mesh applications and infrastructure from attacks. Just a few items to go over before I hand this off to our host, Glen Kosaka, VP of Product Management. Under handouts, we've added the Container Firewall Guide. Please write your questions in the chat box. As we are going through the presentation, towards the end, we will open up for Q&A. This webinar will be recorded, so a follow-up email with the recording will be sent to you shortly after. Glenn, do you want to take it from here?
All right, thank you, Young, and thanks everyone for joining us. I'll be your host today, and today we have a special guest who is Arpad Kun from IBM Cloud, and then we also have Chip Hwang from NeuVector. So our agenda today is I'm going to talk about, let's take a step back and first discuss why it's so critical to secure your containers, and if you're thinking about deploying a service mesh, that as well. And then Arpad is going to cover what is a service mesh and what are some of the features built into the ISTIO service mesh. And then after that, I'll do a brief overview of NeuVector, and then Chip will do a live demo of NeuVector, as well as how that could apply in a live service mesh environment running ISTIO on IBM Cloud. All right, so let's go ahead and get started. Why is security so important? You may have heard of some of these well-publicized breaches of companies that are moving to the cloud, or in the case of Equifax, it was an Apache Struts application that was exploited, or vulnerability that was exploited. And we actually see quite a few Apache Struts applications running in containers these days. So be sure that those do not have that vulnerability. We also saw some of the first disclosures of major security vulnerabilities in the actual infrastructure. So the tools that you're using or thinking of using, whether it's Docker or Kubernetes, have been found to have critical vulnerabilities. Last November, the Kubernetes API server vulnerability was disclosed, where an attacker could gain control of the API server and compromise all the pods running. And just about a month ago, the Doomsday Docker security hole, as ZDNet calls it, in Run C, the Docker runtime, similar where an attacker could escalate their privilege to root and therefore do some bad stuff in the container environment. So not only do you have to worry about applications running in containers being hacked, but also the infrastructure itself. And the same will also apply to a service mesh technology that we'll cover today. So in order to best protect against these types of attacks, as usual, it's a layered security approach. There's not one security tool or technique that's going to provide you complete protection. So good, it's like good, better, best. Good is scanning your images, signing them, making sure that there's no vulnerabilities, as far as you know, that are moving down your pipeline. And then better is to make sure your hosts are locked down, you have proper RBAC and access controls for all your orchestration tools, your internal tools as well. And then also you're using all the orchestration security features that are built in. And then finally, for ultimate security for those unknown vulnerabilities, zero-day attacks, no company would go into production without real in-depth layer 7 network visibility and protection, as well as endpoint security. And in the context of containers, endpoints are containers themselves and the hosts. So being able to see what's going on in a container as well as on the host. That's what's required for defense in depth. The reason that you've got to look at the security features of these tools, as well as new container security tools, is that your traditional tools are really blind to all of these attacks. So first of all, if you scan your containers, that's great, your images, but zero-day attacks and insider attacks are still going to be able to get in and exploit your containers. And none of the current tools, traditional tools like firewalls, WAFs, or endpoint security tools can actually see into a container network, look for threats, detect suspicious processes, and all of those things. So all those attacks that you read about in the past are equally as likely to occur in a containerized environment. And an attack, a successful data breach or attack, is not comprised of a single security event. It's really a kill chain of events. And typically they're going to try to get in, they're going to try to expand, and they're going to steal data or connect to command and control. Those are all network-based activities. And so that's why the network is the most critical part to really have deep visibility into. Ultimately, it's your last line of defense. But at the same time, you should be monitoring your containers to see if you can detect the exploit happening within the container, breakouts, privilege escalations, and other things that could occur on the container as well as on the host. All right, so with that background into security, let's take a look at what is ISTIO and a service mesh. Now we're assuming that you're familiar with Kubernetes generally and containers, and we're going to talk about, Arpad's going to talk about a service mesh, which is a layer on top of that. As soon as I can pass the presenter to Arpad, he can start his presentation. All right, there you go, Arpad.
All right. There we go. Show. All right. Can you see it?
Yep.
Okay, awesome. Do you see the full screen?
Yep, it looks great.
All right, okay. Thank you, Glen, and hi everyone. Welcome to this webinar. Thanks for the invite, and I really appreciate being here. So let's quickly address what ISTIO is for those guys who haven't heard about it or you haven't looked at it. So essentially, ISTIO is an open source platform independent service mesh that provides traffic management, policy enforcement, telemetry collection for your application actually that you are running in as a service mesh. But what is a service mesh actually? So it's very simple. It's just basically a network of your microservices. So as we are modernizing applications, from monolith into containerized and microservice architecture. We are breaking these services into microservices out, and we can then create a service mesh from them. And then when these microservices talk to each other to compile, to make this application or service work, that is what we call service mesh, very, very simply put. So the state of Istio was founded by IBM and Google and a bunch of other companies, and it's a very healthy ecosystem, very healthy open source project right now with many developers and adopters. As a matter of fact, I think I have one of the top, or if the top Istio contributor from IBM on the call. So, and I'm just going to cover here the basics. So we are going to do another webinar, hopefully soon, where you can ask her the deep dive questions. She's going to go an Istio deep dive. So this is just to get familiar with the basics of Istio, so we can understand why it is important and how NeuVector can help and fill the gaps where we need even more security and more control. So what does Istio do? Actually, we can break it down into these 4 pieces. So it can connect your microservices in an intelligent way. So these APIs or the APIs call between these services can be connected in a secure way, and you can control who can talk to whom. So you can authenticate, you can enable security like encryption between this between the API or the microservices, and you can also observe. So as you can imagine, when we are modernizing applications and we put more and more microservices into, for example, a Kubernetes cluster, and then the east-west traffic, the chatter between these microservices gets really, really loud, and lots of going on. A lot is going on. You have to understand this both as a developer as well as a security person, and also as an operator. What is going on? Where are my bottlenecks? What is important to focus on if I want to improve my applications performance or availability, or even if I do stress tests to find out where the bottlenecks are. And it's not easy when you are looking at a Kubernetes cluster from the outside to understand what is going on inside and where the bottlenecks are. So Istio can even help with that. So Istio has lots of features. It's a very, very rich and very powerful tool. And we are going to just go through a few of them. So it can do intelligent load balancing. So for example, with the Ingress gateway, you can, as well as from microservice to microservice chatter or talk, you can define how much traffic you want to send to a version A, and how much traffic you want to send to a version B of the same microservice, just by editing configuration files and YAML files and applying to them to Istio. You can enforce the policy, who can talk to whom. You can create a polyglot easily. You can connect a Java application that talks to a Go application that ends up presented by a Node.js application, and Istio sits in the middle as an underlay. And these microservices can talk to each other, and they don't have to even be written the same language, but the same policy, the same encryption across these microservices can be established without modifying the application. It's really, really powerful. And of course, what is also extremely important is in-depth telemetry and reporting. So you can see what is going on in your service mesh. But in Istio, you can only see what is going on in your service mesh, and then Chip is going to show examples why is it important that you have an additional layer. So remember that point, that you only see what is going on in the service mesh with Istio. So before we even look at NeuVector, we have to understand how Istio works, and this is going to be just a very, very high level overview how Istio looks like. So hopefully you can see my mouse. I'm going to use it for just point out a few things. So on the here at the bottom, we have these services that are established by Istio. These they typically run in your IKS or the Kubernetes cluster as pods, and these are the pieces of Istio that make Istio work. So we have the pilot that actually is doing the discovery and config management. So it downloads the config to all the Istio pieces, like the the sidecars that I'm going to address in a second, the policy enforcer that is enforcing the policy, the telemetry that is collecting the telemetry, and you can collect the data and then visualize it, and then also the citadel that does the TLS and MTLS. It's essentially a certificate authority running in your cluster, and it can do microservice to microservice mutual TLS connection and authentication and security. So how does Istio work? So at a very high level, we have service A on the left side here and service B on the right side. So A, these green rectangles are just a microservice. It can be HTTP, something running on port 8080. And you want them to talk to each other. And if it is, for example, an old application, it does not have TLS or any encryption between these two, but you have to modernize it. So, for example, that is a really good example for Istio. And how we can do that is that we insert a sidecar. It's basically another container into that pod. Like Kubernetes pods are a combination of one or multiple containers. So this Kubernetes pod has the application, the microservice, which is a container or multiple, and we put a sidecar in, which is another container, and an envoy that is part from Istio, and it is inserted by Istio into the pod. So essentially, both have an envoy proxy, which is an HTTP or gRPC, HTTP2, a TLS proxy, so it can do anything and connect the services by capturing the port that goes into the microservice and out from the microservice. So essentially, envoy sits in the data path when microservice A wants to talk to microservice B. The whole thing is, as I mentioned, programmed by pilot. So envoy is inserted and then configured by pilot. And then the policy enforcement and the telemetry and everything that runs in the same, usually runs in the same Kubernetes cluster, can be collected and enforced, etc. by these pods that run in the Istio or Kubes namespace, wherever you set it up. So essentially, and for example, the encryption use case. So when I want to secure my communication between two microservices, because if I have to handle credit card data or our personal identifiable information, or if I have to be HIPAA compliant and things like that, and my application is not there yet, or it's very hard for me to recompile and add encryption into my existing heritage application, I can just install Istio and then configure the mutual TLS encryption and authentication between these two microservices, and essentially I get it for quote unquote free from Istio, that I don't have to touch the microservice itself, and it can talk to each other. So Istio is very powerful, and I encourage you to join the next webinar, which is going to be a deep dive. In this slide, the MTLS piece is broken out in a more detailed way. So this is the CA, the certificate authority that I mentioned. It is running in your Kubernetes cluster. And we have service A on the left, and we have service B on the right that want to talk to each other. Envoy is in between, and essentially Istio inserts that certificate, that MTLS certificate, into the Envoy proxy. So this connection here between service A and the envoy is unencrypted, as well as on the right side here, it is unencrypted, but everything that is on the wire is encrypted, because running in these two containers, the envoy and the service, is running in the same pod, in the same machine. So that is basically the same Linux namespace, network namespace. But this can be anywhere in the IKS cluster. It can be even outside. It can be a multi-cluster environment, and you want to make sure that the authentication and security is set up between the two Envoy proxies. So just a few quick words about IBM Cloud Kubernetes Service, or IKS. So we are running a managed Kubernetes service for our customers. More than 50% of IBM Cloud has already standardized on IKS, and all the services IBM Cloud provides are running in Kubernetes. We are using also Istio we are also not just contributing to this the open source project, but also using it. And we are really proud that we are usually the first to come out with the new managed service with the new Kubernetes versions. And yeah, but what does a managed Kubernetes service give to me as a customer? Why should I care? So I, as a customer, I don't have to worry about managing Kubernetes, doing updates, doing the life cycle managing the life cycle of Kubernetes. Every 3 months, I don't have to do an upgrade. I don't have to do a compile and make sure that everything is working. So essentially, we automated the whole upgrade process, and then you can essentially gain a Kubernetes cluster in approximately 50 minutes and then upgrade them approximately the same time without anything further to do. So it's pretty cool. It's pretty easy to use, and we thrive on making it easy for customers to use our product, IKS. So we wanted to make sure that if you want to run Istio, you have an easy way to do that. So we introduced the managed Istio on IKS, where you can actually, with a few clicks, you can install Istio, and essentially. And you can upgrade that with another few clicks later as updates come out. So I just put here a screenshot of how it looks like. So you can install into your cluster. You can click what version you can click the version you want, and then the extras if you want to have a few example samples that you want to test. So you can bring up a cluster. You can start Istio in probably 20 minutes. You have a fully managed and operational Istio solution if you want, and then you can install NeuVector to see what Chip is going to show us later how to do that. So this is my last slide. I wanted to show this so we can understand a little bit more how Istio and how NeuVector fits into this picture, which is really important because there are so many security solutions, there are so many security features out there, but which one I can use for what? So when I step back and look at the landscape, it's really crowded. There are a lot of noise, and there are a lot of overlapping features that I see, and it's really hard to navigate. So I wanted to put this out a little bit just to get where NeuVector fits in, and then we can start from there, in my opinion. So in the Kubernetes world starts from the container. In IKS, we switched to containerd as the container runtime. So it starts from here. Under this layer, under containerd, you can imagine a hypervisor running a virtual machine. So it can be a virtual machine that runs your containers, or it could be a bare metal running containers. It's essentially the same thing from the container perspective. It's just under that there is the physical interface of the physical Ethernet interface that sends and receives the packets. Then we have the container orchestration, Kubernetes. Then we have the Istio. Now Istio is, what is it? Istio is the service mesh connector that makes sure that all the services that are in my cluster can talk to each other in a secure and in a way that I can enforce the policy. But only those communication that Istio knows about are captured and controlled by Istio. So, for example, ICMP or other ports that I'm not capturing in the service mesh. So if I have a service that is on port 8080, and then it talks to another service that is on port 8844, something like, for example, then Istio knows about that because I tell it to know about it. But if there is something else going on, east-west or north-south, and Istio doesn't know about it, it will not show up in any Istio dashboard or any area. So like a reverse shell or any DNS tunneling or any other attacks that Istio is not trained or not programmed to do a service mesh with, it will be not known to Istio. So Istio has security features, but it is not a comprehensive full security solution. It is very powerful for running a service mesh and enabling security within the service mesh. But if you want to run something in production, you need much more than that. And then if we go up the stack, it gets really, really, really complicated when we start thinking about, okay, Knative, which is the serverless or functions solution, one of them that runs on Kubernetes, which also IBM and Google started and we see a lot of traction. So essentially, Istio is also part of Knative in terms of helping microservice to microservice communication, and these microservices and pods are coming and going. So pods get scheduled, pods get killed and then rescheduled. So there's a lot of chatter, a lot of ephemeral things going on in the clusters, and you have to be able to somehow gain control over that and understand what is going on, what is going in and out from the cluster, and also what is going left and right or east and west in your cluster. And then essentially, yeah, all the containers, and then we have the serverless, the cloud-friendly applications, or all the applications and functions that you put on top. So it's a pretty exciting and very fast evolving ecosystem. It totally revolutionizes how we are looking at compute. In my humble opinion, I think it's a very exciting time, and essentially the security and operations and everyone in this space has to catch up what is going on and how we can ensure security. And Glen mentioned this, and this is my last one. Glen mentioned that you have to gain insight what is going on in your container. And I couldn't agree more, because with heritage or with the IDS, IPS, intrusion detection and prevention systems that were at your network edge, usually at the gateways, those points, they have no idea what is going on east-west in your IKS or in your Kubernetes cluster from a container to container perspective, especially if Istio is involved, which does mutual TLS and rotates the keys very quickly. And unless you introduce Istio integrate with the IDS and then you put IDS everywhere, it's a really, really tough problem if you try to solve it in a way that is the heritage way, how we have done protection, firewalls, IDS, IPS in the past. In a cloud native way, we have to change this. We have to change the paradigm, and this is what NeuVector brings, and I'm pretty excited about how it works. And I will give it back to Glen, and thanks for listening.
All right, thanks Arpad for that great overview of Istio and the technology stack. I think our audience is very excited about Service Mesh. It seems to be a hot topic this year. So one question I have for you is, for those in our audience who, let's say they've deployed a Kubernetes cluster and they've got their app workloads running, and they're thinking or planning about moving or layering a service mesh on top of that. Is there any practical advice or tips you could give them as they think about how to move forward with it?
Yeah, great question. And yeah, we hear this a lot. So Istio, again, is very powerful, and we just scraped the surface here. So I strongly recommend to go out and see. We will have a webinar, a deep dive on that also, attend to that. It is very powerful, and you can do a lot with it, but you don't have to start with an all-in with Istio. So you can actually just start looking at, okay, can I do MTLS? And then how can I do that? Start small, start with a few features that you want, prove it that it works for you, prove it under load that it works for you, so you know that how it behaves, what is the performance characteristics, because what you will find, every feature of Istio will have a different performance hit on your cluster. So nothing is for free. If you want to gain insight into your service and your service mesh, you can enable telemetry, and you will have excellent insight, and you will see where the latencies are, service mesh member A talking to member B. What is the latency? Where is the slowdown, if any? And but you will pay for that with CPU cycles. You will pay for that with like context switches, a lot of context switches, a lot of proxy in between, because you can imagine that Envoy captures everything on both sides. So you enabled at least 2 additional proxy hops between your 2 microservices. So you have to test it and see how it works, see and use those features that make that give value for you, see how much it costs for you in terms of CPU and network latency and etc. And yeah, that's it. Start small, experiment, and then move forward from that. Istio is awesome, great tool, excellent features. But I don't advise to go in and install it and enable everything at the same time in production, because you can hit yourself with that. That's it.
Great advice, Arpad. Yeah, I'm sure there's a lot of education and experimenting that needs to go on before you move into production. All right, so we're going to have Chip show how to get visibility into container network traffic and security events, as well as how that looks in a Istio environment. Before I do that, since Chip is going to be using NeuVector as the tool to get visibility, let me cover briefly what NeuVector is. NeuVector is a container security platform. The product is a container itself. So you deploy NeuVector just like you deploy any workload using Kubernetes. And once the container is on every worker node, it will start to discover all of the network connections. And essentially, it's a layer 7 firewall between all pod-to-pod traffic. NeuVector, in addition to the threat detection and segmentation on the network layer that NeuVector does, NeuVector also monitors the runtime environment of the container to see all the processes running and the file system activity. Beyond runtime, it is a full CI/CD platform that supports vulnerability scanning from, with a Jenkins plugin, as well as doing image scanning, as well as CIS benchmarks. So it is a complete end-to-end container security platform. So that's what NeuVector is and what Chip will be showing you. Now, one of our customers, John Deeming, who is the VP of PaaS Architecture at Experian, has this advice for you, which is that you should make sure that you have a serious look at what's running inside your container network. This is in a non-Istio environment. You can see how complicated the traffic is and perhaps how difficult it is to detect security events that are going on. So we've worked with companies like that to be able to easily drill down and spot where the action is. You'll see in Chip's demo when he gets to the Istio part that there's an explosion of system traffic between the proxy as well as the control plane and the proxy and the workloads. That should be monitored and secured as well, because as I mentioned earlier, those are potential points of attacks that hackers may try to get into. But if you've got 1,000 containers, you have 1,000 sidecars, Istio sidecars running and all making connections. So it can be quite a mess. And NeuVector helps to simplify that by hiding all the system traffic and showing you just the application workloads to make sure you can see security for that. But at the same time, behind the scenes, NeuVector is monitoring all that system traffic. So as Arpad mentioned, Istio has some great routing and discovery features, as well as some security features like authentication and encryption, but it's not a security tool. So in order to provide true defense in depth, you should consider the layer 7 firewall aspects of runtime security, packet capture, quarantining, all of those things you'd expect in a security tool, as well as the endpoint security to monitor processes and file system activity and all of the compliance requirements as well. So that's a quick background. Now let me turn it over to Chip. Let me give you the presenter, Chip, to show a demo. Hold on one sec. Go ahead, Chip.
Sure. Oh, yeah, sounds good, Glenn. So let me just go ahead and share my screen. Awesome. So I hope everybody's able to see my screen okay. It looks like everybody is.
Yep.
But just to give a little background by my demo environment, it is currently built on top of AKS right now, and it's a simple 5-node cluster at the moment. So when NeuVector is deploying an environment, essentially we deploy 2 separate services, first of which will be called controllers. And the controller essentially is the brains of the operation, basically gets all information located here. And even the web UI you're seeing at the moment is just delivered through the controller. And the way it's deployed, all with a minimum of 3, that way you get high availability. In case one to fail, there's 2 other taking place. Now, the second component that's deploying to a cluster NeuVector is what we call an enforcer. And essentially, enforcer name implies does a lot of the heavy lifting with the environment. It basically detects all the violation and enforcement of any policy with your environment. In the Kubernetes environment, the way that the enforcer deploy is in form of a daemon set. So as a new node is added to the environment, a enforcer is automatically added on top of it. So for today's demo, I'm going to focus on two separate things. First, I'm going to show you how NeuVector works in the environment within ISTIO. Then I'll switch over to ISTIO environment to show how the same feature applies. Now, what I'm showing you right now is a network activity page. And essentially, this page will show you all the network activity, the topology map with your environment. So on the left-hand side, these are the Kubernetes control traffic that have collapsed in namespace. As you can see with NeuVector, we can monitor those and protect those as well. But for today's demo, I'm really focused more on the application side of things. So when an application is deployed into a NeuVector monitor environment, the first thing we do is go through what we call discovery phase. And the purpose of this is really to understand everything about each of the services in terms of what network connection required, what process run environment, so we can create a baseline and lock it down. So for my test application, essentially it's a very simple application that composes of 3 separate services. It has an Nginx, which is actually a load balancer, and then it has 3 web services and found to Redis pod. So what I'm going to do is I'm going to go ahead and generate some traffic in real time so you can actually see how the behavior learning from NeuVector works. So that Nginx service is actually exposed externally through a service. So what I'm doing here is simply creating a curl command to generate some traffic. So as you can see here, based on the traffic generated, NeuVector will max out entirely end-to-end how the traffic flow in this case. So for my curl command, it shows the ATM command coming from the external network, coming to the Nginx, and then how it distributes traffic between the web services and finally to the Redis pod. Now, while NeuVector is mapping out how network flows, in the background, we're actually creating whitelist rules to allow communication between these services. So for example, in this case, if we look at Redis, this is how these 2 servers are communicating. The way that NeuVector is determining that the user Redis profile is not based on port number, we're actually using deep packet inspection to determine this is Redis and creating a whitelist rule for it. So even if using customized application or customized port in this case for the Redis protocol, NeuVector will be able to detect that and create a rule specifically for it. Now, even in this particular discovery phase, NeuVector still protects your environment. And what we mean by that is we're still looking for any form of network attacks. So in this case, in the background, I went ahead and generate attack in this case. As you can see here, first of all, we do alert you of it with alert you here, but we also indicate the type of protocol is used for attack. In this case, it's ICMP. But if I dig a little bit deeper, it'll tell me that this attack is actually the ping death attack, which is a well-known denial of service attack. So as part of NeuVector's auto response, first of all, as you can see, we do create an alert. But in addition to this, we automatically do an automatic packet capture of basically the attack itself, the basically identifier that shows you what type of attack it is. In this case, what I'm showing you right now is a particular packet that has the indicator that is a denial of service attack. Now, what I'm taking here is basically the network rules page. So based on the traffic that's generated previously, this is all the network rules that's automatically generated. So these are the whitelist rules. And the way that NeuVector defines a rule is not based on IP address or port numbers. It's done from service to service. As you know, with containers and Kubernetes, containers can come and go, IP address can change. So applying this from the server's perspective, as new containers are added to service, these rules will apply as well. So when these rules are defined, you can go in and start taking a look at them. If there's any specific rules on the list that does not fit your environment, you can go ahead and delete it. But of course, if you see any rules that's not automatically detected by NeuVector, we also give the availability to define your own rules as well. And we make it very flexible in how rules can define. You can define by IP addresses, port numbers, and essentially any metadata from Kubernetes or from the runtime environment, whether it's containerd or Docker itself. Now, in addition to the network baseline we also create a baseline for all the processes within service itself. So in this case, for my API to server service, these are all the different processes automatically detected within my environment. And same thing with network rules. If you see something that's there that should not be there, you can delete them. Or if you see something that should be there that's not, you can add them as well. So for example, in this case, you know a shell. A shell should never be part of a process within your runtime environment. So I'm going to go ahead and delete that. Now, with all the information that NeuVector has collected from a network perspective and process perspective, the next phase is really to be able to lock in your environment. Now, when we lock down the environment, essentially there are two modes we're allowed to go into. First of all, it's called monitor. And what monitor is saying is any violations or threats you detect from a network perspective or a process perspective, do not do anything actively stop the behavior. Rather, just alert me about it. Where in protect mode, NeuVector is in line with all traffic, and see anything that's malicious or a threat, it will actively drop the connection. But anything with a known good whitelist rules in place, it will still allow that connection to flow. So what I'm going to do is I'm going to put this particular service into monitor mode. One thing you'll notice is that this particular service is now purple. So this is an indication that I put my service in monitor mode. But you'll see that my other service is still in blue. And the reason is because the NeuVector gives the flexibility to define how each service needs to be protected, whether it's in monitor mode, protect mode, or leave in discovery mode for a new application. Now, what I'm going to do in the background is I'm going to go ahead and actually move the rest of my services into monitor mode. So just a FYI, every configuration I'm doing with the web UI can also be done with the CLI or the NeuVector API. So we give a lot of flexibility in terms of how you want to automate your environment. Now, in addition, in the background, what I went ahead and generated some traffic that actually should not, that I do not have a whitelist rule for. So for example, between this service, I noticed that they're trying to communicate using Redis protocol, which there's no rule in place. As you can see here, we will general alert for you. But let's say between two traffics, two flows in this case. But let's say, for example, in this case, I have traffic in place in which there's a whitelist rule for. So even though we have a whitelist rule in place, as you can see here, NeuVector is constantly using deep packet inspection to look at the traffic itself. So even though I'm allowing HTTP traffic between them, if there's an embedded attack, NeuVector will be able to detect that and actually alert you on it, as you can see in the particular case. So we dig a little bit deeper in this case, we know that embedded attack is a HTTP request smuggling. So we talked about monitor mode. The next mode when we talk about it is really protect. So if you notice here, all my service is now in green. This is an indication my service is now in protect mode. So every single violation or threat that previously mentioned before, rather than just learning about it, NeuVector will actively drop those connections, but continue to allow good traffic to go across. So NeuVector can alert you with monitor mode. It can also block traffic with protect mode. But in addition to this, we also have more advanced responses as well. So we can create what we call response rules. And this is a way really to customize the response for any type of threat or attack with your environment. So some of the things we can do in this case is what we call quarantine. A quarantine is essentially saying any containers that's found to be malicious or basically creating violations. Let's put a bubble around it. Do not let any traffic in and out of it so it cannot do any damage, but keep it live so you can go back and get relevant information, such as looking at all the processes in it or the command line history. Another thing we can do is basically generate a webhook. A webhook is a way to basically integrate third-party tools, such as a SIM or maybe a service creation system. Now, using a webhook in conjunction with the NeuVector API, we can do much more custom responses, such as taking a packet capture. So one thing you'll notice here is that there's a Icicle Attack here. So as part of my automated response with part of my auto response detecting all the packet cap detecting Icicle Attack, I can actually automate packet capture, which is what I've done here. So you can see here that I just went ahead and doing a packet capture in this case. And from here, I can download and examine Wireshark to have a better understanding how that attack took place. So another thing you'll notice here is basically there's a bubble around this container. So I went ahead and generated DNS tunnel, which is a data exfiltration. So with an automated response, I basically said, you know what, if you detect any type of DNS tunnel, go ahead and put a bubble around it. So no attack, so essentially no traffic coming in and out, but we're keeping it alive to get forensic information. Okay, so this is what NeuVector can do from a network perspective for a non-ISTIO enabled environment. And so now I'm going to switch over to what it looked like with ISTIO in place. First of all, you'll see that what we're showing here is basically an ISTIO enabled environment. Majority of the traffic you're seeing here is ISTIO control traffic. You saw definitely an explosion of it. And as you can see here, this is traffic that NeuVector can monitor and also protect as well. But we also give you the ability to really just focus in on your application containers and basically remove all the different noise. So one thing you'll notice with the ISTIO environment is now we have a new icon, and that's what we're showing here. This is an indication that this particular pod is actually part of Service Mesh. And if I click on So if I click on the detail page for a specific pod, you'll notice that showed me all different containers within it. First of all, it does show me that it has an ISTIO proxy, and also it has basically the application container as well. So as you know, with Arpad mentioning, within every single ISTIO pod, there's actually an operating container. And so what NeuVector is doing now is actually tracking all the traffic end to end. So in this particular ISTIO environment, mutual TLS is enabled. So all traffic between the pods are encrypted. So what ISTIO is doing is actually tracking the traffic end to end. First of all, it track the SLS connection to Envoy, but it also track the traffic from the ISTIO Envoy container to the application container itself. And because of that, NeuVector continued to do deep packet inspection and to look for threat as well as segmentation on the application layer. NeuVector will continue to also be able to monitor anything that falls out of scope from an ISTIO perspective. So for example, protocols that's not supported by ISTIO, such as ICMP or UDP, NeuVector will continue to still be able to segment those traffic and also look for threats and violations with those protocols as well. So this kind of gives you a high-level overview of what NeuVector can do, as well as NeuVector can do from an ISTIO-based environment. So I'm going to go and turn over to Glen.
All right. Thank you, Chip. Just to summarize, that's, you saw how you can get visibility, network protection in a Kubernetes environment, and then when you layer a service mesh on top of that, how that can be monitored, including. Sorry there, I was on mute. So to summarize, Chip showed you how to get visibility into a Kubernetes environment, as well as to detect attacks and threats, as well as how that would look in an ISTIO environment, even with encryption turned on. So it looks like we have time for a couple questions. So if you have a question, do put it in the question box. Let's see. Let me start. Maybe this is, yeah. Was there a?
Yeah, I have a question, which just want to reiterate. So, like when we look at this diagram right now, so in the upper left corner, I see a pod, and then there is Istio proxy. So I see that the Istio proxy is Envoy. Is that right?
That's correct. Yes.
Yes. So I see that the Envoy, it talks to another Envoy on SSS. So no DPI will catch what is in there, because the CA, the certificate authority, everything is inside the cluster, highly probably not integrated with any deep packet inspection service. So it will be just the SSL. But I can actually see what is going on inside the pod between the Istio proxy, which is Envoy, and the microservice. That is actually doesn't hit that traffic never hits the network. So it doesn't. You never see this on the pipe on an Ethernet or anywhere across Kubernetes worker nodes. But still, I have the ability to do the deep packet inspection and catch if there is an attack inside the service mesh after the packet comes out from the Envoy.
Yeah, that's correct, exactly. So because where NeuVector sits uniquely within a cluster, it can detect all traffic within it, not only traffic between Istio containers, but also between the Istio container to the applicant container itself. So because of that, we can look at the unencrypted traffic, even though that traffic does not hit the wire at all.
I think that's extremely powerful. Like this is something that you wouldn't be able to do with any heritage or anything that is not cloud native and not container ready. Because this way I can detect attacks from an insider, as I think Glen mentioned, that insider attacks are getting more and more common. And also if there is an attack against my application and that tries to go out and that tries to do a horizontal attack to other microservices, I can capture that without even letting it to go anywhere in my cluster further. It's amazing.
Yeah, that's correct. This is the integration with Istio that we announced at IBM Think about a month ago. So it's the ability to see this unencrypted traffic. Let's say this pod is sending it through the proxy, and then on the other end, it's being decrypted by the proxy on the other end. So we're able to see both ends and actually put them together and show you the connections and do the deep packet inspection. Okay, so another question looks like for Arpad, is Istio a replacement for Nginx, or will it work with Nginx?
It's a good question. It really depends on how we look at what you think behind Nginx. So if you think about, and I will make a few assumptions, and then please do a follow-up if you have still time, we'll address that. But if I think that you ask whether is it a replacement for the Ingress controller, so Istio has an Ingress gateway that can act as an Ingress controller, or it can sit behind the Ingress controller, and your Ingress controller, which can be Nginx based, or it can be AJ proxy based, or it can be Envoy based. It doesn't matter. It can sit behind. So it's up to you. It's up to your use case and your appetite and your application, what you want to solve. So like, for example, some cloud providers have managed ingress controllers, like IKS has it. And there are some annotations that are used by customers, and they don't have it in Envoy yet or in ISTIO yet. Although there are most of them, or I think by now almost every single one of them is also supported by the Ingress, ISTIO Ingress gateway. So you should be able to choose whatever fits you the most.
Okay, thanks, Arpad. And speaking of ingress and egress, maybe this question is for Chip. So how can the connections that are going out, I guess those are egress connections from a pod outside the cluster, be monitored?
Yeah, definitely. So the same way that the way that NeuVector tracks all connections in and out, as well as east-west within the cluster. So with NeuVector, we can definitely monitor egress traffic and apply rule sets as well. So for example, if you want to make sure that no traffic that's unencrypted leaves your cluster, we can definitely do that.
Okay, thanks, Chip. Let's see, another question from Roberto. Which vulnerability scan is used? I guess which technology?
So from a NeuVector perspective, essentially we can scan we can scan your images for an entire CI/CD pipeline. So we do have a Jenkins plugin that essentially can use NeuVector you can leverage NeuVector to basically scan your build to determine vulnerabilities. You can create policies around failing it. So typically the next phase is really going to registry itself. And again, you can leverage NeuVector to scan any registry, whether it's public or private. And we make that very, very simple. But let's say, for example, during the scanning phase, something made it past your build phase, your registries, and go directly into runtime. NeuVector will continue to scan that container. So any image deployed to runtime, NeuVector will scan it. And if you modify that particular container during runtime, NeuVector will rescan it again. And we also have integration with mission controllers, so essentially configure Kubernetes. Anytime an image is deployed to Kubernetes, you can use it to ask NeuVector if that's something deployable, and then we create policy around it. If there's too many vulnerabilities or if there's misconfiguration within it, NeuVector can tell Kubernetes not to deploy that particular image.
Yeah, thanks, Chip.
What is the? I think. Sorry, I think I heard something in the line of the question, and might be wrong, but I think I heard also that you are scanning against CIS benchmarks. So I think maybe the question was towards what kind of
yeah, we do.
Vulnerabilities are against. Oh, good.
Yeah, Docker and Kubernetes CIS benchmarks. And then I don't know if this was the intent of the question, but we're not using like a third party or open source scanner. NeuVector has developed its own vulnerability scanner. Another question, I think this relates to, the recent Docker security flaw. What about container breakout security flaw found in the runC container runtime, allowing malicious containers to overwrite the host runC? So I think the general question is, when the actual daemon or API server, the infrastructure is hacked, what can be done about that? I'll start with a comment on that, and Chip or Arpad, you can add to it if you want. So NeuVector is going to monitor all the connections between the system containers as well as the application workloads, as you saw. So we're going to detect any attempt to modify any containers that are running, any breakouts that involve a network lateral movement that is not on our whitelist is going to be detected. As well as within the system containers, any suspicious connections. Now, it is certainly possible that if you are able to get into the API server, I think you have bigger problems. You're going to be able to bring down your entire Kubernetes infrastructure if you're at that point. You will get a bunch of alerts from us before that happens, so at least you'll get notified. But I think you have bigger problems at that point. Let's see. Is there anything to keep in mind regarding security when you set up Istio, or is it secure by default? Like the configuration, the default configuration of Istio, is security turned on, or are things turned on?
So I would rather let my colleague answer this in the next webinar, but I will just give a short answer here. So Istio tries to, when you install it, it tries to be secure right now with the configuration. And to that extent, for example, that the egress gateway is blocking everything that tries to go outside of the Istio service mesh. The egress gateway is essentially that piece of Istio that captures everything that tries to connect to the outside, to the public, to the internet, or something outside of the Kubernetes cluster, and that is basically denied by default in the current version. And in 1.1 it will be opened up, because, for example, if you deploy Istio to an operating environment and you do not define your external dependencies, what are the dependencies that your microservices have in order to operate? So they have to reach out to somewhere outside. By default, if you deploy Istio, it will essentially break the application immediately until you define those external dependencies that you may not even know about, which is pretty cool. But I think the community had an outcry that this is too harsh or something like that, and in 101 it will be enabled by default, and you have to set it up. So yes, it's like a balance between security and features and how you use them. But security is never on by default. You have to tailor it for your application, because the best security is that if you don't provide any access to anyone, right? That's the best security. But that doesn't work in our world. So I don't like that. I don't like to call something it is secure by default, because I don't think that exists until you fine tune it to your needs.
All right, thanks, Arpad. All right, looks like we're out of time, so thanks everyone for joining us. As Arpad mentioned, we do plan to have a deep dive on Istio deployment, monitoring, and security with his colleague who's on the Istio contributor team. If you do have specific topics you want us to address in that follow-up webinar, please email us at info@neuvector.com. And with that, we'll be sending all of you the recording. And thank you very much, Arpad and Chip, and everyone for joining us. Have a great day.